All right, everybody, here we are for another video in our statistics class. So let's talk about where we have been in order for me to tell you where we are now in this video. So in the last video, we learned what the mean, median, and mode were and how to calculate them. So I want to do one quick example just to refresh that a little bit and get you thinking about it before we talk about what's new in this video. Okay, so I have a raw data set here of the age of students in a class at TCC. And, this might look more or less typical. The age range of students in a class at TCC, at least to me, kind of depends on what time of day the class is and what the class is and so on, but this is realistic enough. Okay, so let's say I calculate the mean. How do we do that? So you add up every single data entry and then you divide that number by how many data entries there are. Okay, so I'll get a mean age of 25.4 years old. All right, and then the mode is the most frequent data entry. Okay, so I see 18 twice, but then I see 21 3 times. So 21 years old would be the mode. Okay, and then the median is the one in the middle. So why is 21 years old the median? Well, because let's see, there are 11 data entries here. And with this one, as the data are ordered from least to greatest, I see that there are 5 below it and 5 above it. So that's how you find the median if there were an odd number of data entries. But again, for all the ways that you might calculate the median, you can look at the other video that I did on that. Okay. All right. Now, well, notice two of these numbers are different. It turns out that the median and the mode are the same, and then the mean's different. And so why do we learn to calculate all three of them? And is there some kind of consideration where we might choose one number over the other? Okay, because you might think when we do statistics, the idea would be to take some raw data, a big group of numbers, and then simplify it somehow, either by making a graph out of it or reporting a number. Okay, I say, well, the mean age is 25.4 years old. All right, that's one number that's supposed to say something about this whole class. All right, now let me talk about some basic facts about this, and then I'll say a little bit more about that data up there. Okay, so basic facts. The mean, median, and mode aim to measure the center of the data set and describe a typical entry. That's the goal. Now, they may not do that though, okay? All right, I mean, it's like statistics is not as exact of a science as you might think. We can calculate these numbers, but it doesn't mean that they'll do what we want them to do. Okay, does the mean represent a typical data entry? Well, what do you think? I don't know. Let's talk more about that in a minute, but that's the question for now. Now, I would say this, in general, the mean is the most reliable of those to represent a typical data entry because it is calculated from every entry in the data set. Okay, like the mode doesn't care that the oldest student was 74 years old. The oldest student could be 84 years old and the mode would still be 21. All right. It's the mean that includes every entry in the data set. And that might seem important, that you'd think that if I was going to tell you a number that meant something about the whole data set, that it would have to include every single entry, like you couldn't ignore some of them. All right. Okay, so that's why, like, generally we say the mean is the most reliable. Now, reliable, does reliable mean perfect? You know, if you have a reliable car, does that mean it will never break down on the side of the road? No. You know, so this does not mean that the mean is perfect and it will always describe a typical data entry, and that's part of the trouble that we have with this, okay, which I'll develop a little bit through this video, but it's the most reliable, okay? And here's the big one. The mean is very sensitive to these things called outliers. Okay, so I think I made a brief mention of an outlier in another video. I can't remember which one it is, but I've mentioned it already. So the outlier of this data set is the one number that's really far away from the other. So I did have this happen, you know, at least once, maybe a few times, when I've had some older students come back to school. You know, they may have been retired, or maybe they were doing a career change. In this one case, there was a man that he had retired, and you know, he just liked going to school. He liked learning new things, and so he was in my class, and he was probably in his 70s. It was kind of like this. But as far as his age is with respect to the other students, that was an outlier. Okay, it was further away than all the other data entries. So the mean can get skewed pretty far away from outliers. It's very sensitive to outliers. Outliers can make the mean not do what we want it to do as far as representing a typical data entry. Okay. Now, so let's do this. Let's look at an example then. Here's my first example, just to kind of get us thinking the right way again. And I want to remind you what an outlier is. So let's look over here to see something a little more extreme. So let's say there's this person, John, and for today I've made John up, okay? But here's John's yearly income over a 6-year period. So maybe when he started out, he's making $28,000 a year. He got a little raise the next year, $30,000. Kept going up, $35,000. And then, well, this year, he made $10 million. Oh, okay, I see. John won the lottery that year. Well, that's good for him, right? Okay, but, you know, he won the lottery that year. I'm not sure why he didn't quit his job, but the next year he was working back at $35,000 a year and then $36,000 a year. Okay, so that's John's yearly income over a 6-year period, including this crazy year where he won the lottery. Now let's see, what does the stat cat have to say about this? How about just to see, let's compare the mean, median, and mode, and to see which one's the most honest. And I guess, like, in honest might seem like a strange word to use in a math class, but statistics can be misleading. Maybe you've seen this before. People are making claims on the internet all over the place, and they always seem to have data to back them up, all right? And I don't think everybody who makes a claim on the internet with data to back it up is actually correct. That's just me, though, all right? But maybe you can share my feeling there. So, but which one of these seems the most honest? So the mean of that data set, the mean yearly income, so I calculated it with my handheld calculator right here. I got $1,694,000 per year. Okay. The median, $35,000 per year. And the mode, also $35,000 per year. Now, like, well, which one seems the most honest? Like, do you think you could say, well, John's mean yearly income was over $1 million a year? Yeah, that number, the mean, is really sensitive to outliers, right? That's like way more than what are the typical data entries? Yeah, late 20s, mid 30s. Yeah, those are typical. Like, this one's not typical at all. And, you know, I wouldn't say over $1 million a year is typical for sure. Yeah, the mean is way sensitive to outliers. But what should you say? Should you say, well, John's mean salary is $1,694,000 per year? Should I say, well, John's median salary was $35,000 per year, or John's mode salary was $35,000 per year. Which one do you think would represent a typical year better? All right, because that's generally what we want to do, right? The goal with using the mean, median, and mode is to, take the data set and give you a number that describes a typical entry. And those are the three ways that we can do it. Okay, well, I think the median or the mode, they would represent the most typical one. Okay. So if I was going to report something on this, I'd say, well, maybe John's median salary was $35,000 per year, and then I would feel like I was being honest about that, right? Maybe John himself might rather say, yeah, my mean salary is over $1 million a year, and he wants to sound like a big shot and so on. But like I said, you can be dishonest with statistics. It's not a lie to say the mean is $1,694,000 per year, but I do think it would be dishonest to give somebody the impression that that was typical. All right? Okay. So yeah, if we're going to represent the data set in terms of a typical entry, in this case, the median or the mode. Okay. So that's a basic example that would show you the considerations that we have for the mean versus the median versus the mode. Okay. So let's maybe sum it up with like what I would think of as the big question. Okay, if you're doing statistics, you had to report on a data set. Which one should you use? The answer, although this can be a little bit of a matter of opinion, is choose the one that best represents a typical entry of the data set. Now, why do I say it's a matter of opinion? Well, best is not really a scientific or mathematical word. Best is a matter of opinion, but I think for now we can probably have rough agreement if we saw the mean, median, and mode, and we saw the whole data set. We could probably come to an agreement most of the time on which one of those is the best. Okay. Now, why else do I say it's a matter of opinion? Well, the number John might want to tell you is different than the number me or you might want to say if we were being impartial. Remember, maybe John wants to sound like a real big shot and say his mean salary is over $1 million a year. Where if we're being honest, we'll say, yeah, it's more like the median is $35,000 per year. That would be more honest. Okay, so now that we know how to calculate the mean, median, and mode, here in this video are the considerations on the differences between the three, and if you have all three, how to decide which one is the best.